Good evening, everybody. Welcome to today's class. Hope you're all good. Hope you had awesome days and awesome school days. So, welcome to today's class. So, my name remains Victor, and today we're going to be looking at homeostasis. So, once again, welcome everybody to the class. So, let's have a bit of class rules, before we start off. So, rule number one. Please, everyone, stay muted except when you're called upon to speak. And if you want to speak, please indicate interest by raising your hands using the Zoom application software. And if you have questions or responses, please type them out using the chat box. So once again, a very big welcome to all of you. Let's get into the class proper. So of course, today's class promises to be an exciting one. You're going to be able to learn how to define homeostasis. You're going to be able to explain why we need homeostasis, why our bodies need homeostasis, and you're going to be able to construct a simple homeostatic pathway. So, an icebreaker, yeah. So before we start, let's have a small exercise, yeah. So you're asked to run around the school stadium twice. So using the chat box, please highlight the changes you expect to find in your body as you're running around the school stadium. So let's have as much persons as possible participate in this icebreaker. So you are asked, or you're running around the school stadium, use the chat box and highlight the changes that you expect to find in your body during that exercise. Okay, let's keep the answers coming. Okay, Kende says you're going to start sweating. That's correct. You're going to start sweating. Your heart beats faster. That's correct. Your heart starts to beat fast. So guys, keep your answers coming. And thank you very much for your responses. Please do not forget these responses. We're going to get back to this soon enough. Okay, so homeostasis. Now, everything we know about homeostasis was actually the work done by these two men, Claude Bernard and Walter Cannon. So Claude Bernard was a French physiologist. He developed the concept of the internal milieu. He was actually talking about the internal environment, and he explained that the cells in your body are actually bathed by fluid, actually surrounded by liquid, and that in this liquid we have many factors that come into play, factors such as temperature, factors like pH, oxygen. So he also stated that animals like us, we have the ability to regulate our internal environment by ourselves despite changes in the external environment. That's cool, right? Very cool. Walter Cannon, on the other hand, he coined the term homeostasis in 1926, and he talked about the importance of the autonomic nervous system in maintaining a constant internal environment. What does that mean? He's simply saying that for your body to maintain its internal state, it does not need to ask you for permission. It just does what it needs to do by itself without you even thinking about it. It just does it. Isn't that wonderful? All right. Yes, it is wonderful. Thank you very much, Michael. Okay, so let's go on now to the definition of proper homeostasis. Now, you could define it in any way. But look at this definition, for example. We say homeostasis is the process by which a stable internal environment is maintained despite changes in the external environment. The process by which a stable internal environment is maintained despite changes in the external environment. I'd like to add here that for any action to qualify as homeostasis, it has to be a self-regulating action. Your body has to actually perform that action by itself and not by any other external factor for it to qualify as homeostasis. And also, when we say external environment, it can actually be external influences, not just your external surroundings. For example, your actions, the things you do on the outside of your body can qualify as the external environment and not just your external surrounding. Do you understand that? If you do, please give me a thumbs up. Okay, thank you very much. So we can go on now. So before we move on to the next slide, so please guys, using the chat box, can you give me examples of changes you could expect to have in the external environment? Temperature is correct. Pressure, of course, correct. Thank you very much, guys. Wonderful class we are having. So you're all correct. So these are examples of changes we can expect to get from the external environment. So why is it important? Why is homeostasis important? Like we discussed earlier about the internal milieu, the internal environment, we said the cells of our body are bathed by fluids. And in these fluids, we have variables, we have factors that are at play here. Factors like blood sugar, factors like fluid balance, temperature, oxygen levels, blood pressure, pH. These are examples of factors that homeostasis maintains. However, the trick is this. These factors need to be present in your body at given ranges. That means that, for example, let's talk about temperature. At a certain temperature, your body malfunctions. Below a certain temperature range, your body malfunctions. So your body has to work hard to ensure that your insides are kept at a particular constant temperature range. And that is what we call homeostasis. So it's very important because if your body finds itself outside the ranges of these physical parameters, your body starts to malfunction and the organism could die. That's sad, isn't it? Don't cry. All right. So homeostasis actually works in three basic steps or in three basic stages, and we call them the basic components of homeostasis. We have the monitors. These are the guys that detect changes in the environment. They detect changes in that particular variable. For example, your body is too hot. Sensory neurons in your body pick up that information that the temperature of this organism has gone high. And so what does it do? It sends the message to your coordinating center. And your coordinating center is basically the hypothalamus of your brain. So this center receives the message it has gotten from the monitors and then gives a response or issues an instruction to the regulators in order to achieve a balance, a dynamic equilibrium to ensure that this organism is not adversely affected by this change in the external environment. That's cool, very cool, right? So this is an example of, this is a diagram of the hypothalamus and of the human brain, sorry. And then you can see the hypothalamus there, the gray colored portion just at the base of your neck. That's the hypothalamus. It is the coordinating center of homeostasis. It serves to receive messages from monitors and then initiates responses. It could be hormonal responses using hormones. It could be nervous responses using your nerve cells and your nervous system. So now this is an example of a homeopathic or homeostatic pathway. At the beginning, we talked about you running around the school stadium and then noticing some changes in your body. And some of us said that these changes would include sweating, it would include our heartbeats, we get more vigorous. It includes that our breathing becomes faster and you're all correct. Now, I hope you can see my cursor. Now, this guy, he's not actually running around the school stadium, he's not, but he's actually skipping. That's another example of a vigorous exercise. So from the picture, you can see he's sweating, isn't he? He's sweating. His temperature has increased. So the question now is, what does your body do to ensure that this increase in your body temperature does not adversely affect your internal milieu or your internal systems? Now look at the brain here. The coordinating center turns on cooling systems. How? It has gotten the information that your body temperature is high. I'm talking about your hypothalamus now. So what does it do? It sends instructions to your regulators. We have two regulators here in this diagram, and those are the skin blood vessels and the sweat glands. So your brain tells your blood vessels to dilate. That means to relax, to expand, increasing the flow of blood to your skin, causing your blood vessels to be as high as possible so that the heat present in it could actually exude and evaporate into the external environment. So when that happens for a while, your body temperature starts to decrease and then your body starts to cool. Now, the second regulator is your sweat gland. You notice that when you sweat, when your temperature is high, you sweat. Why? Your body, your brain is actually telling your sweat glands to initiate sweating, causing water in your body to evaporate onto your skin. And that has a cooling effect, calming the temperature. And when that happens for a while, your temperature starts to drop off and then your body starts to cool. So this is an example of a homeostatic pathway. It's wonderful, isn't it? So we have talked about what your body does when your temperature is high, right? So what do you think your body would do now when your temperature is too cold? Now look at this particular pathway. Look at it in reverse. Now use the chat box and explain to me. Your body is cold. The environment is very cold. Your hypothalamus has gotten that information. Now, what instruction do you think it's going to give to your skin blood vessels? Is it going to ask you to dilate this time? Exactly. Linda says not dilate, but constrict. Yes, it constricts, causing your blood vessels to withdraw further inside your body, trying to, hold the heat that it has for itself so it doesn't lose excessive heat because your body is cold, the external environment is cold. So it has to hold on to the small heat that it has. Now, what about your sweat glands? Do you think you're going to sweat when the weather is cold? So you don't. So this is how the hypothalamus initiates responses to maintain the internal state of your body despite changes in the external environment. All right, guys, so what have we talked about so far? Okay, so we have discussed homeostasis today. We've talked about its definition as a process by which a stable internal state is maintained despite changes, despite fluctuations on the outside environment. We also said that homeostasis is important because it maintains the body's blood sugar, fluid balance, temperature, and other important parameters and variables in the internal system to ensure that the organism continues to function and to thrive. We also mentioned that homeostasis has three components or three stages: the monitors, which are the sensory cells, the receptors, the coordinating center, which is the hypothalamus of your brain, and the regulators, which are special parts of your body that affect the changes that your brain wants for them to do. All right. So thank you very much, guys. So at this point, we'll be taking questions. Please, you can raise your hands if you want to ask questions. Okay, somebody wants to speak. Okay, go on. All right, thank you very much. Oxygen levels. Now you see that sometimes certain activities causes your body to expend oxygen at a higher level than normal. For example, when you're running around the school stadium, you're expending oxygen, you're expending energy because you need oxygen to produce energy. So because of that, you notice that you start breathing faster. Why? You are trying to get in more oxygen to commensurate for the oxygen that is being burnt to produce energy. And you also notice that your heart beats faster, your heart pumps blood more vigorously in order to transport this oxygen acquired to different parts of your body so that they can continue making energy for you to continue performing that vigorous physical activity. So all of these things are the things your body does to maintain a steady internal state or homeostasis. All right, guys, so my time is up. So before I go, I'm going to leave you with a project. You saw the model I gave to you earlier about how your hypothalamus turns on your cooling system. So I want you to use that same model to explain how your body reacts to a cold environment. So thank you guys. I expect to get your projects by next week. By next week, so have a wonderful weekend, and my regards to everybody. Thank you very much. Goodbye.